I have a magnificent view. Beautiful white mountains, high summits, and together with a friend, we are enjoying the freedom, the thrill of climbing this mixed rock ice wall. And the thought of the even better view from the summit gives us the motivation to battle this mountain. And then suddenly I wake up. Everything around me is black, totally black. Yes, this is my life now, living in total darkness. 6 years ago, I had a high-impact accident. I fell 15 meters and landed on a concrete floor. I broke almost all my bones in my body. Even my eye sockets, my optic nerves were shattered. Damage where no doctor could cure. And does it mean I have to live in total darkness forever? Will I ever see my wife again? Will I actually see my kids grow up? And one day, my neurosurgeon called me and told me about an extraordinary development in the Brain Institute here in Amsterdam. What I work on, Professor Pieter Roelfsema will explain you now. Pieter.
Yeah, so I was trained as a medical doctor, and then I decided to go into brain research, so I'm a brain scientist now. And I've been studying what happens in the brain when you see something. When you see something, when you shift your attention from here to here, or when you try to act upon what you see. And in my research, we started to implant electrodes, just another word for wires. Many of these electrodes we implanted in the visual cortex, and several years ago we realized that this actually gives us a very exciting opportunity to perhaps in the future restore a rudimentary form of sight for people who are blind. And I would like to explain to you how this might work. So the idea is that the future user of our visual prosthesis will wear a camera, for instance in the glasses, and the eyes are not functioning, so we are going to directly plug the information from the camera into the visual cortex. Okay, it sounds maybe futuristic, but we think we can do it. So I will tell you a little bit of how this might work. So what you see here is 2 brain cells and a wire. We call it an electrode, I told you that. And in purple is actually the place in the visual brain where we want to place our electrodes. It's actually in the back of the brain. And we place an electrode there, and we can then artificially activate those nerve cells with just a tiny bit of current. And what then happens, and it also works for somebody who has been blind for several years, is that this person will see a dot of light. We call it a phosphene. Now, if you would then place the electrode, say 2 or 3 millimeters, say to the front, and you stimulate again, then somebody sees a dot of light at a slightly different position in the outside world. And it turns out that everything we see is systematically mapped out on our primary visual cortex. It's really a map of space. So if you would then implant, say, 1,000 electrodes, we can create 1,000 phosphenes, these artificial dots of light. And we can work with it like a matrix board that you know from the highway, right? So if you switch on one bulb on the matrix board, you see a dot. But you can also create patterns by switching on multiple lights at the same time and leaving out others. That's how it works. Now, this is very ambitious, and you should realize it requires brain surgery. So before we really test this in humans, we really have to make sure that this is safe and that it can work. So that's what we are now working on. And in the last couple of years, we have been testing this in monkeys. And we trained these monkeys. So they were looking upper left at the red dot. Then we trained them to recognize letters. So here they saw letter D. And then they saw a choice menu because we wanted them to report to us what they just saw. And then they were supposed to make an eye movement in this choice menu to the same letter they just saw. Okay? Now, the exciting part of the experiment is when we don't show the letter in the middle anymore, we replace it. We just activate artificially a set of neurons trying to paint a letter directly onto the visual cortex. Big question is, will the monkey report the letter that we're trying to paint? And the answer is yes. So what you see here is really data from the lab. So the blue dot is the location on the screen where the monkey directs his gaze. That's what he looks at. And you see the white dots. These are the cells that we electrically activate. So here it's a letter T. The monkey reports a T. A letter O. Monkey reports an O. We were really excited when that worked. We made a small dance in the lab. Okay, so this is proof of principle. We can make this work. But it doesn't mean that we have solved all problems. So there's one problem is we need to kind of address all the visual field. If we place electrodes in only a subset of this region, then the subject, the future user, will only be able to see these phosphines in one part of the visual world. We want to get them everywhere. That's a challenge. The second challenge is you have an immune response of the brain. So the electrodes that we've been using so far, they work for about a year, and then there is fibrous tissue, an immune response that pushes the electrodes out of the brain. Okay, so you don't want to do a brain surgery to somebody, and then he can see for maybe about a year, and then it stops again. So we really have to solve that problem. And I think we know how to do this. So there are other types of electrode technologies that should allow us to make this work. Now, one question you might have is, what would it be then to be a future user of this visual prosthesis? And I'm going to demonstrate that to you because colleagues of mine in the artificial intelligence department at Radboud University in Nijmegen, they made this simulation. Okay. So this is, what people who are wearing the visual prosthesis might see. Okay? So I see a lot of pixels. I can also see my hands. Can I see where the stage ends? Maybe I shouldn't try. But I do see Hein. Hein, can you wave? So you see, it's not superb, but it's probably going to be much better than seeing nothing. Yeah. And now I'm going to give the word back to Hein.
Yes. And to make this possible in the future, there's a lot of effort needed, a lot of research. Not only help for me, for the future, but millions of blind people in the world. And not only my dream will come true, but more important, I will be able to see the people I love most again. Stepping out of total darkness into light again. miracles exist.